Okay, we have a bag full of 9 counters. 2 of the counters have a number 1 on them, 3 of the counters have a number 2, and 4 have the number 3. We're going to reach into the bag and pick out 3 counters at random. And we want to work out the probability that the total of the numbers, when you add them up on the 3 counters, is 6. So, let's start by working out the different ways you can pick 3 counters that do add up to 6. Well, you can pick a 1, the first pick, and then a 2, the second, and then a 3, the third, because 1 plus 2 plus 3 is 6. You could do a 2, then a 1, then a 3, and so on and so on. So all the combinations of 1, 2, and 3, they all add up to 6. And the only other way of doing it is picking 3 2s, because 2 plus 2 plus 2 is 6. And there are no other ways of doing it. You can't pick, say, 2 1s and a 3, for example, because that's 5. Anyway, so we reach into the bag, and the first counter we pull out is a 1. Then the second pick is a 2, and then the third pick is a 3. So that's the first way of getting a total of 6, because 1 plus 2 plus 3 is 6. Okay? So what's the probability of picking a 1, then a 2, then a 3? Well, the first time we reach into the bag, there are 9 counters. So it's going to be out of 9. And the probability of picking a 1, well, there's 2 of them. So it's 2 out of 9. Now you know that the probability of doing something and then something else, you multiply. So the probability of picking a 1 and then a 2 is multiply the probability of a 1 by the probability of getting a 2. So, given that we've already picked a 1, what's the probability of picking a 2 with the second pick? Well, how many 2s? See, this is probability without replacement, and so that means you have to bear in mind you've already picked a 1 with your first pick, and that affects this second probability. So you have to bear in mind that one of those 1s is no longer there, which means there are only 8 counters in the bag, probability without replacement. How many 2s are in the bag? Well, we didn't pick a 2 the first time, we picked a 1, so there are 3 2s in the bag. So the probability is 3 out of 8. Okay, and then we multiply again by the probability of picking a 3 on the third pick. How many counters are in the bag now? Well, there's 7, because we've picked a 1 and a 2, they're gone. How many 3s are in the bag? Well, we've still got 4 3s. So, that is the probability of picking a 1, then a 2, then a 3. Okay, how else could we do it? Well, you could pick a 1, then a 3, and then a 2. So let's work out the probability of doing that. Well, the first pick, probability is the same. It's still 2 9s. Because there are 9 counters and there are 2 1s. Right, what's the probability of picking a 3 with the second pick? Well, there are 4 3s still in the bag, but now there's only 8 counters, so it's 4 8ths. And the probability of picking a 2 with the third pick, well, there are 7 counters left in the bag. We haven't picked a 2 yet, so there are still 3 2s. There. And that value is actually the same as that. Because look, we've got a 2, a 3 and a 4 on the top in both cases, and a 9, an 8 and a 7 in both cases. So they're actually, the probability of doing that is the same as the probability of doing that. Okay, let's write down the probability of picking a 2 first, then a 1, then a 3. Okay, 2 with the first pick is 3, because there are 3 2s out of 9. Okay, then multiply, picking a 1 with the second pick. There are 2 1s, but there's only 8 counters left. And then a 3 with the third pick, there's still 4 3s left, and there's only 7 counters left. So, oh look, again, it's the same. You've got a 2 times a 3 times a 4 on the top, and you've got a 9 times an 8 times a 7 on the bottom. So, can you see that however we arrange these, it's always going to be the same value? So we can actually crack on fairly quickly with the other possible combinations. A 2, then a 3, then a 1, it's all going to be something over 9 times something over 8 times something over 7. The 2, there are 3 2's. The 3's, there are 4 of them. And the 1's, there's 2 of them. So then we've got a 3, then a 1, then a 2 to do, then a 3, then a 2, then a 1 to do. And again, it's going to be the same value, just the 3, the 4 and the 2 are in different orders on the top. So a 3 is 4 out of 9, a 1 is 2 out of 8, and a 2 is 3 out of 7, and a 3 is 4 out of 9, then a 2 is 3 out of 8, then a 1 is 2 out of 7. Okay, so that's all the different possible ways of picking a 1, a 2 and a 3. There are 6 ways of doing it. So we've dealt with the 1, 2, 3 combination. Now we need to deal with the 2, 2, 2 combination. So what's the probability of picking a 2, then a 2, then a 2? Well, the first time you reach in, there are 3 2's and there are 9 counters. The second time you reach in, there's only 2 2's left and there's only 8 counters. And the third time you reach in, there's 1 2 left and only 7 counters. Okay, so that's the 2, 2, 2 case dealt with. So, the probability of choosing 3 counters whose total is 6 is that plus that plus that plus that plus that plus that plus that, because the probability of picking 1 then 2 then 3 or 1 then 3 then 2, in the case of or, you add the probability. So it's that plus that. So therefore the probability of picking that or that or that is that plus that plus that. So the probability of picking that or that or that or that or that or that or that, covering everything, is that plus that plus that plus that plus that plus that plus that. So we've agreed that these first 6, the numerical value is the same. It doesn't matter the order of multiplication, you've just got a 2, 3 and the 4 on the top, and there's 6 of them. So the total probability, the thing we want, is 6 times this, 2 out of 9 times 3 out of 8 times 4 out of 7. Okay, that's that plus that, which is 3/9 times 2/8 times 1/7. I'm not going to bother with brackets. You don't need them because of bid mass. Multiplication takes priority over addition. Okay, so that's it. That's our answer. Let's work it out. Don't just dive straight into the multiplication. Cross cancel first to simplify, or just cancel. So we've got a 3 there, which goes into 9 3 times. 2 goes into 8 4 times. Okay, what about over here? 3 goes into 3 once, goes into 9 3 times. 2 once, 4 times. Oh look, that's nice. 4 and a 4, it's gone. I think that's it. Okay, so it becomes 6 times 1 1 1 on the top. 1 times 1 times 1 is 1. 3 times 7 times 1 on the bottom is 21. Plus 1 times 1 times 1 on the top. 3 times 4 is 12. 12 times 7 is 84. Okay, so that's 6 over 21 plus 1 over 84. Luckily 21 goes into 84 4 times, so 6 times 4 is 24 over 84 plus 1 over 84. 24 plus 1 is 25 over 84. That's it. That is our answer. That's the probability of reaching in, picking 3 counters whose total adds up to 6. And we can't simplify that any further, so that's the final answer. Nailed it!